Okay, so I wanted to give you another application of this new formula, again with using z is equal to the x bar minus mu over sigma over the square root of n. So I'm going to show you parts of 31. So this one is about a company that says they produce AA batteries. It says the mean life of these batteries follow a normal distribution. Notice they give you the mean is 35 hours. So that means mu is 35. It says and a standard deviation of 5.5, so sigma is equal to 5.5. It says as a part of its quality assurance, however, they test a sample of n is equal to 25. So it looks like that's going to be our sample size. So again, part A, whenever you get a question, it says, what can you say about the shape of the distribution? Just the basic idea is this is approaching 30, which is for the central limit theorem. We're going to say basically it's large enough to be a normal curve. That's really all we're going to be looking for. So I'm just going to say for part A, just basically it's going to be a bell-shaped curve. Part B says, what is the standard error of the mean? Well, remember, if you just take sigma divided by the square root of n, this part of the equation, that's also referred to as the standard error of the mean. So again, if you take 5.5, which is sigma, and divide by the square root of 25, that's going to give you a standard error of 1.1. That's all they mean by that. So that would take care of part B. So then, just like we did earlier in one of the previous examples, it says part C, what is the proportion of the samples that will have a mean useful life of more than 36 hours? So proportion, probability, area, all means really the same idea. So again, I'm going to go down here, draw my curve, just to give you the visual. So 35 is going to go there. And it says more than 36. So again, here's 36. Draw my line. We want that area. We got to convert 36 into a z-value. So it's going to be 36 minus 35. And since we already did this calculation, you're going to just divide by that 1.1. And in this case, you're going to get a z-score that's equal to 0.91. So when you look up 0.91, which is right here, that gives you 0.3186. But that gives you from here to there, that's to the left. So basically you take 0.50 minus the 0.3186, and then that would give you the area, which is about 0.1814. So that's just the basic idea. So just again, it's just like before, once you know you have sigma and the sample size, you might want to do that calculation first because that's always going to be your denominator when you get your z-score. But once you get that, when you're plugging these in to find all these answers, it's just like we did in chapter 7. It's no different, just basically now we're factoring in the concept of sample size. So that was part C. And just kind of wrap it up, I'm not going to show you all of them, but like if they did part D where it says what proportion of the sample will have a mean useful life greater than 34.5, again, it's the same idea. 35 goes in the middle. We know that 34.5 would be less than the mean, it'd go right there. So since it says more, we're going to the right. You simply have to convert this into a z-score, and hopefully you'd know that you just take 34.5 minus the 35, divide by the 1.1, and that would give you a negative 0.45. And of course, you just got to look it up. So again, just trying to show you this is the same stuff we've been doing, but now what I would suggest you do is as you read through these is to maybe write out your symbols. That will simplify it as you extract the data out of the problem. That way you know pretty much what to plug into this formula. So again, I hope this one helps.